Okay, what we're doing today here is we're going to do conversions, but the conversions that we're going to look at are going to be a little harder than what we've seen before. All right, the first question we have: the deepest part of the Pacific Ocean is 5,968 feet fathoms deep. What is this depth in meters? One fathom is exactly 6 feet. Okay, so having that information, we have one fathom is 6 feet. Another way of writing this is 6 feet. For every 6 feet, I have one fathom. Also, we need to know, is there a relationship that exists between between feet and meters? And we do know that for every 12 inches, we have 1 foot. And another way of writing this is that for every 1 foot, I have 12 inches. And our next relationship that we have is that we know that for every 1 meter, I have 39.7 inches. So 39.7 inches, or we can say for every 39 point, so this should be 37 inches. For every 39.37 inches, I have 1 meter. This is a 3 here. So in this problem, the way that we want to attack it is we want to go from fathoms to feet to inches to meters. So when we set up our problem is going to say how many meters is equal to 5,968 fathoms. And we have to use a relationship that will allow us to cancel out fathoms. So again, whatever you want to cancel out, the relationship should always be in the denominator, and whatever you want to keep should be in the top. So and if we look at our first one here, this relationship causes our fathoms to be in the bottom. So we can have for every 1 fathom, we have 6 feet. Fathoms here cancel out. Now if we stop at this particular point, our answer will be in fathoms. But we don't want our answer in fathoms, we want our answer to be in meters. So in order for our answers to be in meters, we need to have another relationship. And we know that for every 1 foot, we have 12 inches. This would cause feet to cancel out. And again, from our relationships here, we have two relationships. We want the relationship that will cause whatever we have in the numerator to cancel out. So since we stopped here and it's in feet, we want feet to be able to cancel out. So whatever conversion that we use has to be in inches, or has to be in the denominator of whatever conversion we have. So in this instance, this is the most appropriate conversion. So now we're almost there. We are in inches. We want to go to meters. The next thing that we have is to use our relationship found here. We want inches to cancel out. So we have to use relationship that will allow the inches to cancel out. If we use this relationship, inches will be in the numerator, meters will be in the top, which is exactly what we want. If we use this relationship, meter will be in the denominator and inches will be in the top, which will cause inches not to be able to cancel out. So here we have for every 1 meter, we have 39.37 inches. Inches cancel out. So we have 5,968 times 6 times 12 times 1 divided by 1 divided by 1 divided by 39.37 inches. When we do the calculations for this, this would be equal to 10.91 meters. All right. Okay. Let's look at a problem a little bit more interesting. This problem here says the mean distance of the Earth from the Sun is 1.496 times 10 to the 8th kilometers, which is defined as 1 astronomical unit. The mean radius of the Moon's orbit around the Earth is 0.00257 AU, astronomical units. The mean radius of the Earth equator is 6.378 kilometers. The distance from the Earth to the Moon is equivalent to how many trips around the circumference of the Earth equator? Now, when you read this equation, when you read this, it's like so much information is thrown out at you. So, calm down. It's not that hard. Again, we're just converting. We have to convert from one unit to the next. So the first thing we want to make sure is that all our units are in the same, and that what we're looking for, we're sure about what we're looking for, and we know what the relationships that exist in the problem. So the first thing that we're told is that we have 1.496 times 10 to the 18th kilometer, which is defined as 1 astronomical unit. So that's the first thing that we need to write down. So 1 astronomical unit is defined as 1.496 times 10 to the 18th kilometers. And the other way of writing this is 1.496 times 10 to the 18th kilometers is defined as 1 astronomical unit, right? AU. All right. So that's the first thing that we need to be able to do. So we're told that we have the mean radius of orbit around the Earth is 0.02570 astronomical units. So this here is the distance from the Earth to the Moon. And we can find out what that number is in kilometers by using our relationship that we just defined. So 0.0022570 astronomical units. We use the conversion that we have here, and we want to use the one that has the astronomical units in the denominator, which is this one. So we have 1 astronomical unit is equal to 1.496 times 10 to the 18th kilometers. Astronomical units cancel out. This number here is equal to 3.845 times 10 to the 5th kilometers. So this here is our distance to Moon. Now, the problem says the mean radius of the Earth, the mean radius of the Earth equator is 6378 kilometers. This is from the Earth is equivalent to how many trips around the circumference of the Earth. So